Hello and welcome back to the lab. Today on the bench we have another one of these Wavetek Model 166s. This is unit number 2 that needs restoration. I am assisting a technician with some experiments, getting some function generators up and running for them so they can play around in their lab. But we got one done. I have a couple more in the queue, and I also have a couple other Wavetek units that are going to see the bench in the near future. So we'll plug it in, turn it on. I'm not expecting a lot given what we saw from the other one. We'll see how it goes. I am going to rebuild the power supply in this one because that did seem to bring the other one back from the dead. If you haven't seen that video and the problems that happened there, check that one out. It'll be further back in the video catalog. But let's fire this one up and turn it on. One of the indicators that the power supply is going to need to be rebuilt is if our light is a little bit dim. We're probably going to have missing rails. Let's hook up the meter just to be safe. All right, so we do have an actual power button. So with the power button out, lab voltage is running about 121 volts. Well, that's kind of bright. So let's throw it in the scope and see what happens. All right, we'll let you guys take a look at the scope. Give it a bit of, turn the readout on so you all can see what we have it set to. That is decidedly DC, but not necessarily a problem yet, because our DC offset is set very high. We are on sine wave, normal sine wave. It's not healthy. Okay, so my attenuation works. That's very stiff. Oh, we are trying to have waveforms. It's trying to live. Okay, so it's not happy. As with all vintage equipment, what we're going to do in the beginning is, well, function changes. So we're going to clean switches and redo the power supply. After that, we'll check power rails. If the power rails are fine, we may have to dive into some additional troubleshooting. But for right now, as always, start with the contacts, start with the power supply, and see where we have to go from there. With the scope, one thing that it did tell me, I had it on DC, not AC, and we had the ground connection hooked up. It was very negatively biased on the 7603. So our output was driven way high to the negative, but it does look like some of the oscillator section and things are working because we had sine wave control. It would change function, like if I had it on sine wave and I switched it, it would actually change. So in terms of functionality, right now I ballparked at about 40%. Doesn't have its mind, but it's not completely dead either. So it does give us a decent starting point. 4 bolts in the back and 1 ground wire later. The power supply is out. The ground connection ties in right here, and is done with a screw, lock washer, and nut combination. Micro wrenches are very useful to get these out. These lock nuts, they are, I'm not sure if I like them or not, but they are highly effective at keeping the bolts tight. The size was a 5/16 for anybody following along at home. And the one connector here is what ties the power supply to the unit. So with that out, this gets out of the way, that gets on the bench, and we're going to feed it some caps. Gonna have to order some more thermal grease too. This rail pushes the pass elements down to the heatsink on the back of the unit. So what we're gonna need to do is loosen these top bolts to get it freed up. We don't need to take the pass elements out of the board, but we do need to free them up so they can come off the heatsink and this back plate can come off to allow servicing of the components. And the board's off, but to save the stress on the component legs, I left the pass elements connected to the heatsink. I don't know if they used a thermal glue or a thermal paste, but this mylar layer doesn't want to disconnect, and the thermal pads, or the pass elements don't want to disconnect from the heatsink. So for the least stress on the components, left the pass elements in place in a quick desolder, pulled them off the back of the board. It will make reassembly a little more tricky to line up the pins and things again, but at the end of the day, it'll be better for the stress on the components. I didn't want to risk cracking the plastic packages. So I got to get all these capacitors replaced. We'll do some testing on them, see how bad they are. They don't look awful. Some of them are starting to corrode a little bit, so it's time, but the meters will tell us what we need. Okay, we have all the capacitors replaced. I was checking them as I was pulling them out, and it looks like the 220 mics that were here and here, these guys were struggling a little bit, starting to dry out and having a bad time. So just that would have justified replacement and refresh. The rest of them seem to be working okay, but since I was in here and it is kind of a job to get this thing apart, just did them all while we were here. So this is ready to fold back up. I got to reattach all the pass elements, and then we should have a functioning power supply. After that, we have to attack the boards in the unit. All right. We don't have everything 100% tight yet. I'm working on getting the pass elements reapplied or reconnected. Getting these done or getting everything lined up was took a bit of doing. But there we go. We'll get this cleaned off. Yep, the flux residue on these capacitors. Okay. Finish tightening up all the screws. We'll throw it back in the unit and see if we have a power supply. As the comment section tells me sometimes, if I didn't film it, it didn't happen. So this is supposed to be a 220 microfarad 16-volt capacitor. The ESR is starting to go a little high, but we're way down on capacitance. So these are starting to have some problems. Here's a 47. Here's one of those 47 by 50s. This one's not too bad. ESR is starting to go a touch high, 0.31. Here's a 2200 by 16. If my hands decide to work. .23, so starting to show a little bit of DC leakage. but the ESR on that one's still all right. Here's one of the thousands. Not too bad. ESR is starting to float a little high, but not respectable for 1,000 microfarads, so not awful. So some of them definitely time to come out and swap out. Some of them were still okay, but we were in there, so we did the whole thing. All right, at this point, I'm ready to do a power on test of this unit. I have it hooked up to the power meter, and the scope's fired up again. I do not expect the recap of the power supply to have made meaningful improvement to the mind of this unit. So what I'm looking for in this test is not a reduction in functionality and no explosions. But we got the camera rolling. If anything exciting happens, you'll be here with me. Well, nothing catastrophically exciting, which was good. We do have that huge negative bias still, and I do see some frequency adjustable ripples. Let me show you what I'm talking about. So if I move the frequency dial, I can adjust the frequency of this not correct waveform. So we still don't have any degradation of signal, but again, as we expected, no meaningful improvement. Next step is going to be to clean the switches very, very well, service all the switch packs, get them up and going. Then we're going to be able to start troubleshooting this piece of equipment, if there is. I'm expecting the switch cleaning to actually have some meaningful improvement and actually get some things working. And I'm going to have to work on that for a little while and get everything ready to go. So let me get started on that, and then I will bring you guys back when there's updates. Okay, so what do we have going on with this thing? We had a decent troubleshooting session last night, and I think I got a bit more information, but we're going to take a quick look. So, essentially, we have a signal with an extremely negative bias. Not a negative bias, but it driven extremely negative on the scope when it's DC coupled. So that's telling me the negative rail is at least present and sane. The positive rail might be dead. Not 100% sure yet at this point. But this is the schematic for the main board. So to say there's a lot going on here is an understatement. The real question is, do we have a problem in the power output section, or do we have a problem generating the waveform? Is the power amp doing what it's told, or is the power amp screwing up? That's the real question that I want to answer right now. We had a couple of test points. We got test point 3 and 4, which are our power supplies for the power output section. Now, if the power amp's being told to go extremely low, we might be shorting out the positive rail, and that could cause what we're seeing on the scope. We have a pretty good idea that the sine converter is working and a couple of other things are working just because of the way the scope is and the waveform's changing when I click the function. So, as I said previous, we're about 80%. I do have a test point right here, test point 7, which is the signal that drives the power amp section, coming right out of the final stage of the inverter. So at the output of the scope, it goes through the power amp section, comes down into the attenuator, and the attenuator is 100% resistive. Because the attenuator's working, I would imagine these resistors are probably fine. So I'm going to focus the troubleshooting effort on the power amp section. Testing test point 3 and 4, we do have a good negative voltage. We do not have a great positive voltage, so something is not quite right. Popping the power supply off the back of the unit, and my positive and negative rails are both present. So, is now something shorting out the negative rail, or the positive rail in the power supply, and the negative rail's controllable, which is driving the signal highly negative. We want to take a look at test point 7. Test point 7 is hiding right underneath here. This transistor. This is the resistor. It's a 10 ohm precision resistor. This is where the shaped signal comes out of the shaping circuits and goes into the power circuits. So if we had good sine wave signal here, that's going to eliminate most of the circuitry in here and let us focus on this area as the fault in question. It turns out we do have a good sine wave signal here at test point 7. So that leads us to the power amp section is not doing what it's told. We also have a problem on this with ground. When I was doing scope measurements, there was a whole bunch of 60 hertz noise. Nothing was working right. Turns out they have this wonderful ground connector coming off the power supply that's supposed to ground out the chassis and a couple of other things. But they didn't remove the paint off the grounding lug, so it's trying to ground to paint. That's not working too well. So we'll correct that while we get this thing up and going. But I'm starting to suspect the output stage in here is shorted out. So I'm thinking, given that we have good signal out of the shapers going into the power amp board, and we have pretty much out to lunch power amp board, I think some of these pass elements might be shorted out. So the first order of business would be to check the power section, especially the stuff on the 22 volt rail. Q44, Q45, 46 and 47, and 41. So 41, yeah, 41, 44, 45, 46, and 47 would be what I would have concerns about at the moment. If those transistors turn out to be good, then we're going to look at diode, shorted capacitor, or something like that. Odds are good it's the active circuitry, not the passives. Passives don't tend to go bad unless they're overstressed. But it's pulling it down so hard that it's actually depleting the filter cap. Could find it with short detection, just inject some voltage and see what gets warm. But we'll test some elements, things like that. The problem is getting to it. On this particular unit, the power section's hiding underneath this board, and there's a shielding board on the bottom of it to keep the power section from seeing this board. So I can either leave the power section in place and take this board out, or we can pull the power supply or the power amp section out and let it come out. Either way, it's going to be a chore to get this thing apart and to get this board out of here. So we will see what we have to disconnect. Success at last! The board is out. This took some extreme disassembly. You have to desolder all of these cables, which are on these BNC connectors here. All of these switches have to be loosened up from the front of the case. The variable potentiometer for the frequency has to be removed from the front of the case. Here's the dial for that. All the knobs have to come off on the front. I started to panic on this board because it looked for a second that it was riveted together. Thankfully, it's just some sockets. These come off. This is that shielding board. And our our power amp section is right here. So, wow, that took some disassembly to get out of there. Let's check some transistors. Things are getting serious if the curve tracer's coming out. So, we're looking at Q46 and Q47. These are the main outputs on the positive voltage side. So these are NPN transistors. We have Q47 and Q46. Q47 is on the right, Q46 is on the left. We have Q47 and Q46. So right and left. 25 volts. These are 2N3866s, 28 volt DC, and they are 400 megahertz transistors. And they have an 800 megahertz current gain bandwidth product. So these are actually pretty quick. So let's see what we have. See if we have luck or if we're in the hunt for transistors. So this is on the right-hand side. I've only got 1 volt per division, so 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 volts on a 25 volt transistor. And we have a characteristic curves of transistors. So the right side device is functioning. Everything looks good. See what the other half of our output section is. Nope. So whatever happened, it appears that Q46 has left the chat. That's 47. 46. Same settings on the curve tracer. So we have a comatose output stage for sure. Here were the two devices that we were testing, and one of them is for sure blown out. So I'm going to have to source some transistors. Well, sometimes in these videos we go until we can't go anymore. I've been poring over some data sheets, and I have not been able to find a suitable transistor replacement for the output stage. Those are some fairly quick transistors, and everything I'm finding is about 30 megahertz, which is even too slow for this function generator because this function generator is a 50. So I'm going to have to work on sourcing some parts for this. So we're going to put this one on pause. We'll call this part 1. And if I do end up locating some parts that can be used to bring this one back, we'll revisit it. If anybody knows any parts that might be a good replacement for these two transistors, let me know in the comments below. And cleaning off, they are 2N3866 non-A devices. So if anybody knows a suitable replacement for a 2N3866, let me know, and we'll see if we can get this function generator back up and running. For right now, we're going to loosely put this back in the case so it's protected, and let it set for until we find some devices. With that, thanks for hanging out. Thanks for watching. And if you've gotten this far in the video, hit the subscribe button, like button, let the YouTube algorithm know, and so we can forward the channel on to anybody who might run across it. The Patreon page is ahead on videos from the YouTube page. Everything will end up on YouTube eventually. Patreons just are ahead, and their support helps out the channel and keeps the lights on. Their help assists way more than anybody knows. So with that, I will see everyone in the next video. As always, more is always on the way, and we will get some stuff, and we will get some things up and running. Bye for now.